All right, hey gang. I'm sorry that I didn't record this second half when we did the first half, so we'll just get right into it with the proof here in number 17. So the first thing I'm looking at with the two congruencies, the two pairs of angles that are congruent, I'm looking at the picture right now and I'm trying to evaluate which pair of triangles I know the most information about. And really, if I trace the angles that are marked congruent, you can see which triangles we want to prove congruent. So if I go ahead and redraw that separate from the picture, we have something that looks like this. Okay? And so what I'm going to do, now just looking at this picture down here, is I'm going to go ahead and identify something that's congruent in both triangles. And that would be that AD is congruent to AD by the reflexive property. Okay? Now by me stating this one step, I now know that triangles are congruent then by angle, angle, side. Angle, angle, side. So I can go ahead and state for a third step, triangle ADC is congruent to triangle ADE by angle, angle, side. Okay? Now that I've got the triangles congruent by angle, angle, side, I then am going to go ahead and ask myself, can I prove these two segments in BD and FD congruent? Okay, so back to what I was saying, the proof, we're trying to prove BD is congruent to FD, but the problem is down here in these two triangles, I have neither of those segments. So now I'm back to the drawing board. What can I do? Well, as I look at what I have left, the two triangles that have BD and FD, if I was to redraw both parts, so I can redraw these two triangles here, and I'm marking everything I know to be congruent as of right now, okay? I don't think there's anything else I can prove congruent. I can't prove these two angles congruent. These two sides aren't the same sides from the previous two triangles, so I can't claim that they're congruent. And yeah, if this is the ultimate goal, these two triangles just can't be proven congruent. So now I go and I take a look at these two triangles, okay? And so what I'll do is something like this. I'll try to redraw those sets of triangles there. And now I ask myself, what can I prove in these two triangles to be congruent that isn't already proven to be congruent yet, okay? My hope is that you guys automatically start to think in this manner. Hey, we've got vertical angles. I can prove them congruent. Now this angle here would be angle BDC. So angle BDC is congruent to angle, I'll do FDE, by the vertical angles theorem. Okay, vertical angles theorem. Now, the next thing I need to do is I can't prove anything else in these triangles congruent right now. But what I could do is go back to these two triangles and ask myself, is there anything from these two triangles that is the exact same in these two triangles? And what I see is that this segment here, CD, and this segment here, DE, these two segments are the exact same in the both sets of triangles. So I'm going to go ahead and say that CD is congruent to DE. By what reason? Well, these parts correspond within the two triangles. So, and these are congruent triangles, so they have to be congruent. So it's by CPCTC. Now again, remember, what does that mean? Corresponding parts of congruent triangles are congruent. Now in the meantime, I'm going to go ahead and mark those segments congruent out on the paper there. And what I now see is that these two triangles are now congruent to each other, okay? So I'm going to go ahead and write for number 6, triangle BCD is congruent to triangle BCD FED by angle side angle. Okay, angle side angle. And then, if the triangles are congruent, does that mean that BD will be congruent to FD? Yes, it does. Okay. So BD is now congruent to FD by CPCTC. Okay. All right. Now, on to the coordinate geometry down here. Okay, so let me read this. It says in triangle ABC is an isosceles right triangle. Here's the right angle. So that means that this length here is the same length as this length here because it's isosceles. Both legs are congruent. If I was to draw it out, isosceles right triangles would look like this. We'll talk more about those later on this year. And point B is the midpoint of AC. So if this is the midpoint of this segment, what else do I know that is occurring on this segment? Well, it would be that this segment here is the same length as that segment right there. Okay? So with that in mind, let's see here. What is this entire length right here? Well, this is a length of A, even though it's going in a negative direction here, it's a length of A. This is also a length of A. So the whole length is actually 2A. 2A. Okay? So if I want to go ahead and figure out what the ordered pair for C is going to be, here's what I need to think. I'm at 0, 0. I'm going to go over how far? I'm going to go over A units. And I'm going to go up 2A units. So as a result, C is going to be A, 2A. Okay? Now, to get B, the ordered pair for B, obviously it's 0 for the x value. But we're going up how far? Well, what I want you to know, I think I'm going to show it like this. Go ahead and do that right there, okay? If this is the midpoint, these lengths are both the same. But what I want you to know is that what I've just created are two congruent right triangles, okay? And I could mark it out like this by hypotenuse angle or angle side, being that these angles are corresponding and they'd be congruent to each other, okay? So as a result, I know that if this length here is equal to this length here, that this one has to be A and this one has to be A to make 2A, okay? So I'm actually going up A and that's it. So 0, comma A would be the ordered pair for B, okay? So let's see here. Did I answer all these? What is the coordinates of C? Again, C is going to be A, comma 2A. B is going to be 0, comma A. The slope of AC here. Now, if my ordered pair is this, here's A and C, we're going to do the slope formula, which if you remember, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So we have 2A minus 0 over A minus negative A. Okay? Now, 2A is just left in the numerator. Denominator, this actually becomes a positive. So I have A plus A, which would be 2A as well. And anything divided by itself is always 1. So the slope of that line is going to be 1. Okay? What's the length of AC? Well, again, I'll put A down here. C is going to be A, 2A. Okay? Again, I'm going to put the x sub 1, y sub 1, x sub 2, y sub 2. And the length can be found by doing your distance formula. So x sub 2 minus x sub 1, y sub 2 minus y sub 1. Okay, I'm going to remove this down so we don't go off our screen here. All right, so if I go ahead and plug in the values, let's see what we have. A minus negative A. Okay, so again, a minus negative a. And then we're going to do the y value is 2a minus 0. Okay, so the distance here, we're still on the screen, good, okay. A plus a is 2a. And then again, we have 2a right here, okay. Now, as I work this through, you're going to have 4a squared right here. This is 4a squared, 2a times 2a. And you have 4a squared right there. Okay. Now, 4a squared plus 4a squared, well, what's 4x plus 4x? That's 8x, right? So if I do 4a squared plus 4a squared, that's going to be 8a squared. Okay. Now, how do I simplify this? Remember what I said before about these. I'm going to write this in expanded form. The factors that go into 8 would be 2 times 4. And 4 can be broken down into 2 times 2. So here's 4 times 2, that's 8. And then a squared would just be a and a. Okay? Now, what does this end up becoming? That becomes a 2. Square root of 4 is 2. This becomes just a. So we end up having 2a radical 2 as our length there. Okay. Now, don't worry there, folks, about that, simplifying the radicals and everything like that. I'm not going to put that on the test, but I thought it was good to review how to plug everything in, and hopefully that all makes sense to you. Okay. So I hope that's good. Have a great night, and I'll see you in class. Hopefully you can knock this test out of the park. Thanks for your time. Goodbye.